Let's take a look at board now. And what do we have here? So you can see I've got the ocean and I've got the seafloor right in here. Okay, so let's draw it a little bit thicker here. Okay, this is the oceanic plate. It's typically basalt, ultramafic rocks. So for example, here is basalt, dark colored. Think of it as lava, dark colored lava. Okay, and that comes from out here in the mid-oceanic ridges where magma rises up. And the crust is pretty thin right in here. And so we actually get a ridge as the new material comes up that can be seen from sensitive equipment looking down at the bottom of the ocean. Okay, so we have these mid-oceanic ridges, for example, in the middle of the Atlantic Ocean. And then as the seafloor spreads, this could be upwards of 200 million years old it's taken to get, let's say, to the Andes Mountains. And then there's a bunch of material, let's say muds and sediments. Let me show you a picture. Here where I live in Northern California, we are at the bottom of the ocean. And so these muds and sediments have been metamorphosed into this mudstone. However, as the sediment, mud, and so on is pushed down into and underneath, it is scraped off. And so you get lots of sediment that accumulates right in the trench here. Eventually that could get to the surface, okay, and create like our coast range in California. Also, water is going to be brought down with the plate and actually melt the plate. It's going to melt the oceanic plate. And so I've drawn that here with these plumes of magma, these plutons. Okay, now I assume most of it doesn't make it. I'm a geographer, not a geologist, but my best guess, is that it's difficult to get to the surface, particularly if it's very viscous, not very easy to flow. And so these are going to be our intrusive features, our intrusive rocks that we talked about already. For example, granite. All right, so there's some granite. And some of that magma is going to get to the surface and become a volcano. So here's some of our landforms right now as magma rises to the surface. So I want to zoom in and take a look at a few other features here. Okay, let's take a look at some of the landforms created by subduction. If we take a look here, I have a volcano. Volcanoes have different kinds of lavas, as I have talked about before. Let's talk about basalt. So basalt, which is a little bit more runny, usually makes it to the surface, or can. Other kinds of lavas that are thicker, it's going to be a little more difficult. So the majority of magma is going to probably stay beneath the surface and then eventually be exposed. So in Northern California, here in the foothills, we have lots of granites, and this would have been in place probably 150 million years ago. So this is 150, 140 million years ago. Here would be the plumes of magma that eventually cool, and during that time there would have been basalts and other kinds of lavas. That is now largely gone. The ancestral Sierra Nevadas is gone. A lot of that sediment ends up out here in the Great Central Valley, along with marine sediments, and the fact that as the seafloor is spreading and butting up against the continent, it actually starts to dip it down. It starts to fold it. So there's another kind of geologic process. It folds it, it faults it, it deposits material, which is now over 10,000 feet. The Great Valley sequence is over 10,000 feet. That's where we grow lots of our rice and our tomatoes here in Northern California and other kinds of agricultural wonders. Okay, and so I'm going to then finish with this over here. This is our California Coast Range. This is sediment that's been scraped off the seafloor. And I wanted to move on to another episode or video that talks about accretion.